In this video, let's see interconnection of three windings in three-phase system. In three-phase system, there are three individual identical windings like this. Each winding is having starting and finishing terminals. It is denoted by SR and FR for R phase, SY and FY for Y phase, and SB and FB for B phase. If three phases are individually connected to load like this, it requires 6 terminals or 6 conductors. So it is expensive and complicated. So this type of system, that is three phases are individually connected load, that is also three-phase system. This circuit is termed as, or this system is termed as non-interlinked three-phase system. To solve this expensive and complicated system, we will go for two types of interconnection, that is star connection and delta connection. Star connection is also known as Y connection and delta connection is also known as mesh connection. In star connection, similar terminals, that is starting of the winding or finishing of the winding of three windings are connected or joined together. So it will form a common point that is known as neutral point like this. Here finishing end of each phase FR, FB and FY are joined. That forms a common point. That point is known as neutral point. If we are taking a wire from these neutral terminals, that is termed as neutral wire. And this wire is phase wire, that is R phase, and this is for Y phase and this is for B phase. So this is the schematic representation of three-phase star connection. Similar way we can connect load also in three-phase manner like this. So this is the schematic of three-phase star connected load. In three-phase system, as we discussed earlier, the voltage across each winding is termed as phase voltage. That is, V phase is the voltage across the starting terminals of the winding, or simply phase with neutral. That voltage is V phase. Here it is VRN, if we are denoting these neutral terminals as N. Similar way, we can have VYN and VBN as V phase as shown here. And these terminals RYB is termed as line terminals. When we are measuring the voltage across R and Y, two terminals, two line terminals, that is known as line voltages. So here we can have VRY, VYB and VBR as the line voltages. In a three-phase star-connected system, if neutral wire is also available externally along with three-phase winding terminals RYB, then totally 4 wire will be available for external connection, that is R, neutral, Y and B. This three-phase configuration is called three-phase 4-wire system. If neutral wire is not available externally, then totally 3 wire only will be available for external connection. Then that three-phase configuration is termed as three-phase 3-wire system. So this is the schematic representation of three-phase 4-wire system. This neutral wire is connected to the neutral point of this star connected load like this. So this is phase wire. This is also Y phase wire. This is another phase wire, that is B phase wire, and this is neutral wire. So under balanced condition, ZR is equal to ZB is equal to ZY, that is corresponding phase impedance are same. Under that condition, the magnitude of individual current, that is IR, IY and IB should be same. with mutual phase difference of 120 degree. The instantaneous value of current IR can be expressed as Im sin omega t, that is Im sin theta. Iy is equal to Im sin omega t minus 120 degree, that is Im sin theta minus 120 degree. And similarly, IB is equal to Im sin omega t minus 240 degree, that is Im sin theta minus 240 degree, or Im sin theta plus 120 degree. From this figure, it is clear that current flowing through neutral wire is the sum of IR plus IY plus IB. Substituting IR, IY and IB just like this, we can see that IN is 0 ampere. That is instantaneous current. That is instantaneous value of current flowing through neutral wire under balanced condition is 0 ampere. So, in a balanced three-phase system, current through neutral wire is 0, or voltage at the star point or neutral point is 0 volt. So under this condition, that is balanced condition, neutral wire can be removed without affecting voltage or current in circuit as shown in this figure. Here, for external connection, only 3 wires are available, only phase wires are available. There is no neutral wire. So this configuration is 3-phase, 3-wire configuration. So in 3-phase system, the terminals R, Y and B are called line terminals. The voltage across any two line is called line voltage. Voltage across one winding, that is one line and neutral, is called phase voltage. Current through one phase, that is one winding, is termed as phase current. It is represented by IPH. And current through lines, that is known as line current, that is represented by IL. In three-phase star-connected system, current flowing through this R phase is exactly equal to this line current. That this is line terminals. So current flowing through this line terminal is IR. That is exactly equal to current flowing through this phase. Therefore, I phase is equal to IR, that is I line in the case of star connected system. But when we are considering this neutral, the potential between this neutral and line, that is VPH, and the voltage difference between two lines, that is R and Y. So VRY is obviously greater than that of VRN. Therefore, we can say that in three-phase star-connected system, V phase is not equal to VL and I phase is equal to IL. Let's see the relationship between V phase and VL later. Next interconnection is delta connection or mesh connection. In this method of interconnection, dissimilar ends of the three-phase windings are connected together. That is, finishing is connected to starting, or starting winding is connected to finishing winding, like this. So this is the schematic representation of delta connected system, and R, Y, B are line terminals. In delta connection system, we can have 3 external terminals. So as 3 external terminals are there, this system is a 3-phase, 3-wire delta connected system. As we know, the voltage across one winding is termed as phase voltage, and voltage across two terminals or two lines are termed as line voltage. When we are comparing these two, we can see that in delta connected system, line voltage is equal to phase voltage. But when we are considering this current flowing through this R phase, which is nothing but I phase, current flowing through B phase, that is I phase, current flowing through Y phase, that is I phase, but current flowing through this terminal is IRL, line current. So when we are comparing these currents, we can see that IRL, that is line current, and phase currents are not equal in the case of delta connected system. That is, in delta, I phase is not equal to IL, but V phase is equal to VL. In a balanced system, the sum of voltages in a closed mesh is zero. The three EMF are equal in magnitude but differ in phase from one another by 120 degree. That is, VR plus Vy plus Vb is equal to 0, which is equal to Vm sin omega t plus Vm sin omega t minus 120 degree plus Vm sin omega t minus 240 degree is equal to 0. Here we already discussed three-phase four-wire system. This is a source and this is load. So here load is star connected and source is also star connected with neutral. So this configuration is termed as three-phase four-wire system. Similar way we can connect star connected load with the star connected source in three-phase three-wire system manner like this. I am giving some work to you. You need to draw different source and load arrangement in star connected and delta connected configuration. So please draw these four interconnection configuration. First one is draw interconnection of three-phase star connected source with the delta connected load. Next one is draw interconnection of three-phase delta connected source with star connected load. Next one is draw interconnection between three-phase delta connected source and delta connected load. And finally, I am giving some question to you. Is three-phase four-wire configuration is possible in delta connected system? Please justify this question by giving proper answer.